Finding me x, finding me y. So in the first one, from the video that you should have watched over the weekend or after the test, you should have realized that there is a 1 to 1 to the square root of 2 relationship in a 45, 45, 90 right triangle. Okay? Meaning that the two legs of a right triangle are the same, and the hypotenuse then is the square root of 2 times the leg. Well, if we set that up, we've got a 1, or our hypotenuse is 1. So to go from the square root of 2 back to 1, I would have to divide by the square root of 2, which means to find me the length of the sides, I would have to divide by the square root of 2. So we'd have 1 over the square root of 2 for both of those sides. Now, we don't like, I shouldn't say it, we're okay with radicals in the bottom, but we also like the process of rationalizing our denominators, because everything that we're going to do today, tomorrow, the next few weeks is going to have rationalized denominators. Okay? So we would multiply this by the square root of 2 over the square root of 2, because that fraction is equal to 1. Doesn't change anything. So x here is equal to the square root of 2 over 2. In a 30, 60, 90 triangle, we have a 1 to the square root of 3 to 2 ratio, shortest to longest. Shortest side is opposite the 30-degree angle. Middle side is opposite the 60-degree angle. Hypotenuse is the longest side. So shortest to longest, that's the ratio. If, again, in this case, my hypotenuse is 1, then I would have to divide all of them by 2. So my long leg would be the square root of 3 over 2. My short leg would be 1/2. In this particular case, because we are looking for the side across from the shortest or the smallest angle, we are looking for the shortest side, so that would be 1/2. If you remember your special right triangles and or you watched the video from this past weekend and remember it, that should have taken you that long. Probably should even take you a shorter time than that. Okay? So today we're going to start to work on the unit circle today. Okay? So at some point in time we will be developing our own unit circle, or your own unit circle. You will be developing it, so you will need a blank sheet of paper at some point in time. However, we don't need it just quite yet, so you can start taking notes. We'll get to it towards the end of class today. We'll finish it tomorrow. Okay? So we're going to be talking about the unit circle, and the unit circle is a circle. I know, shocking, okay, that the unit circle is, in fact, a circle. I'm getting my notes up for, oh, nope, that's not the one that I wanted. I want 4.3a, there it is. That's the one that I wanted. There we go. Okay. So the unit circle, or I'm sorry, an equation of a circle. Now, we didn't do conic sections this year, but a circle is what's called a conic section. Okay? It has a center, In this case, in the unit circles case, the center is at the origin. In the unit circles case, the radius, distance from the center to any point on the circle, the radius is equal to 1. That's why it's called the unit circle, okay? Because the radius is 1 unit. Okay? And the equation of that circle then is the equation x squared plus y squared is 1. Okay? So the coordinates of any point on that circle, if we take the x coordinate and we square it, add it to the y coordinate squared, that sum will always be equal to 1. Okay? Now, knowing what we know from our theta work from 4.1, okay, we can pick any point on our circle. So I'm going to pick this point right there. It's going to have coordinates x comma y. Okay? This central angle right here, as long as I'm measuring it in radians, that central angle there, let's call theta, would have the same length, or I should say that theta then, is going to produce a RAP value. Now we call the RAP value T. Okay? So T right there is going to also equal theta. Because in 4.1, we talked about the arc length is equal to the angle in radians times the radius. Well, our radius is 1. So whatever our central angle is, as long as it's in radians, that RAP value is going to be the same. Okay? Now, how we do this, or the way we go about doing this, is because, so we can move this point. Now, here's where I wish I had animation. Okay? I haven't gotten that far into the smart notebook yet to figure out. But if I move this point, whoa, tab brakes can't move that point. I want to move this point. See, it rotates around the center. I can't lock it in. So if we went to any point, I'll go in purple this time. If we go over here, okay, so now my point's over there. So now here is, we'll call it theta prime. It's our second theta. Then the length of this purple arc now is theta prime. And that would work for any point on our unit circle, where the length of that arc is going to be the central angle in radians. Put it into words. Each and every t value, our RAP value, corresponds to a point on the xy or in the xy plane. We are finding two different ways to get to a point. Okay, that's what trig does for us. it gives us another way come on back up, to get to a point. So if I want to go to my red point, I could Batman and Robin it. I could drive down this road, make a left turn, and drive up that road and get to the point. That's our old school Cartesian coordinate system. Okay? The purple one, I could drive down this road, and drive up this road, get there. Okay? Trigonometry says, or we can just go along the circle. And we can find the coordinates that way. Okay? So our our RAP values also correspond to our central angle. All right. In trig, on the unit circle, we have 6 wonderful, awesome operations, functions, whatever you want to call them. Okay? The first one is cosine. We abbreviate to COS. Okay? At some point in time, you're going to say cos or cos. And I'm going to say, huh? And I'm going to say, oh, you mean cosine. Right? Cosine. Okay? Even though we write it shorthand, it's cosine. Cosine is going to be the x part of any point on the unit circle. Okay? Cosine is x on the unit circle. But it's got to be on the unit circle in order for it to be x. Sine. At some point in time, you're going to call it sin. And I'm going to say, we're not at church. Okay? It's sine. Sine is y. It's the y part of any point on the unit circle. What do you call a guy at the beach? No, you call him a tangent. Get it? Tangent. Okay. Tangent, you're going to refer to it at some point in time as tan, and that's the one that you really get. Tan, it's tan, it's tan. Tangent of any point, or of the angle, is equal to the y value over the x value. Or oops, I put x, those should be t's. Those 3 you've probably heard of. Okay? The next 3, I think you heard of them in Algebra 2 Extended, possibly, but maybe not. Okay? Then everything in trig gets a co. Okay? Remember that. Everything gets a co. Okay? So cotangent is the reciprocal of tangent. Oops, I should put the hold on, tap the brakes. Move this down. I forgot to give you how we write it. We write it as cot. Okay. Cotangent is cot. It's equal to 1 over tangent or x over y. Secant and cosecant are the other two. Remembering that everything needs a co, so secant, or SEC of t, would be 1 over the cosine of t. So that means that it would be 1 over x. Because cosine already has a co. Sine doesn't have a co, so it gets cosecant. Cosecant is CSC of t. Which is 1 over sine, which is 1 over 1. Okay. Where we're going with this. Okay. So the first thing that we have to determine is we have to determine if this point, negative 5/13 comma negative 12/13, is a point on the unit circle. Because if it is, we can then find all 6 trig values of it. Okay? All right? So the unit circle equation, again, was x squared plus y squared equals 1. All Cartesian coordinate points are of the form x comma y. So we would have to square negative 5/13. We would have to square negative 12/13. And hopefully that sum is equal to 1. Well, negative 5/13 squared. What is that? Negative 5/13 squared. What do you got? 25 over 169? Negative 12/13 squared. Do I have common denominators? Yep. If I have common denominators, what do I do with numerators? Add them. 25 plus 144. $25 plus 144. 169. Is that equal to 1? Yeah, that equals 1, right? So is this point on the unit circle? Yes, it is on the unit circle. So it is so since it is, we were asked then to find the 6 trig functions. Well, we've got cosine of x, or we said of t. Let's go with t. We'll go with cosine. Sine of t, tangent of t, cotangent of t, secant of t, and cosecant of t. Cosine. What was cosine? Looking in your notes. Cosine was x. So the cosine of this point is what? What's the x part of this point? No. Negative 5/13. There is a difference. Oh, should move closer then. We have plenty of good seats available. Okay? What is the sine of t? Negative 12 over 13. What is the tangent of t? Might have to do a little extra math here. What should it be? Or what's the fraction within the 2 fractions? Or the 2 fractions within the 1 fraction, I should say. It's sine over cosine, right? So that means it would be negative 12/13 over negative 5/13. Dividing fractions. 3 words. Say it loud. Keep, change, flip. Which one am I keeping? The top one. What am I changing? Changing the multiplication. What am I flipping? The bottom one. What does that fraction simplify to be? 12/5. Now, the other ones are just reciprocals of them, right? Okay? So what's the reciprocal of the tangent value? What's the reciprocal of the tangent value? 5 over 12. So that's my cotangent. What's the reciprocal of my cosine value? Negative 13/5. You said positive. You never said negative. That's opposite reciprocal. You're thinking perpendicular. I'm just thinking reciprocal. Yep. What's the reciprocal of my sine value? Negative 13/12. And there's the other 6 answers we need. Okay. Once you know, this only works if you prove that your point is on the unit circle. If your point is not on the unit circle, you can't do any of this, because those relationships only hold on the unit circle. Okay? So let's build ourselves a unit circle. Here is where you need a fresh, brand new, nothing else used piece of paper. Okay? in the very middle of your piece of paper, you are going to need to draw yourself a big old circle. And then you're going to cut it in quarters. Okay? So you need to draw yourself a circle. Big one. Cut it in quarters. At some point in time next week, right now we tentatively have it set for Tuesday, but we might move it to Wednesday or Thursday. We don't know yet. At some point in time next week, you are going to have to, or you're going to be given a unit circle memory quiz. You are going to need to memorize the unit circle. Okay? Look at me, buddy. Okay? If you can memorize 37 countries in the Asian world, you can, for whatever it was, that U.S. history, world history, and then there was another one too. Isn't there one for India too? Or is that all in one? One for every country? Oh, so they're making you do multiple memorization quizzes, and we make you do one, and I get this as a reaction? Like, yeah, exactly. That's what I'm saying, Rose. The one time I make you memorize. Because we found over the years, it's much easier if you got it memorized. Because then you just know it and you just do it. As opposed to trying, no. Memorize. Okay? Alright. So there are 16 key points on the unit circle. Okay? Remember, I only just said the quarters right now. Yeah. Okay? So just quarters right now is what we're looking for. Okay? Give me one point that you know is on the unit circle. Pi is not on the unit circle. 1 point. 0, 0 is not on the unit circle. It's the center of the circle, but that is not on the unit circle. 1 is not a point. X, Y is a point, but I want to know a point. 0, 1 is on the unit circle. It is right there. Zero, 1 is a point on the unit circle. Give me another point that you know of that is on the unit circle. 1, 0 is on the unit circle. It is right there. -1, 0 is, and 0, -1. All of those points are on the unit circle. What can you tell me about the x-axis that you drew, which is your horizontal, and the y-axis that is vertical? What can you tell me about those two lines? Say it loud. They're perpendicular. What does that mean? Does not mean that they are the same. They have opposite reciprocal slopes, yes. What about 90-degree angles? They intersect at 90-degree angles, right? So these angles right here are all 90 degrees. Okay? Now, for those of you that remember, 0 degrees or 0 radians starts out straight out to the right. Okay? So then if we go up 90 degrees, this would be 90 degrees up here, or pi over 2 radians. I go another 90 degrees, and now I'm at 180 degrees, or pi radians. I go another 90 degrees, and I'm at 270 degrees, or 3 pi over 2 radians. I go another 90 degrees, and I'm back to where I started, which is also 360 degrees, or 2 pi radians. Those are the 4 easy of the 16. Okay? Because no math was involved in that whatsoever. Okay? We'll come back to this slide here in a minute. Okay? So now we've got, from the video that you were supposed to watch over the weekend, we can remember that we've got a 1-to-1 to the square root of 2 relationship going on with all 45, 45, 90 triangles. Okay? So because of that, if our hypotenuse, which in our case now is, excuse me, the radius so here is our 45 degree triangle. Here is our 45 degree angle, and there. Our radius is 1 because we're on the unit circle, which means then, that's why we did the warm-up problem that we did today, which means then that both of these are the square root of 2 over 2. Which means that this point here is the square root of 2 over 2, comma, square root of 2 over 2. Because this is a 45 degree central angle, that means that this then would correspond to an angle of 45 degrees. If we multiply by, if we convert, I should say, 45 degrees times pi over 180 degrees, pi radians, we would have 45 over 180, which simplifies down to pi over 4. 45 goes into 184 times. So now we can go over here and we can come to this point. Now here is my 45 degree angle. That one bad. .45-degree angle there. Right angle here. 1 there. Square root of 2. Square root of 2. What would the coordinates of that point be? because we're going in the negative direction for our x. Here's where things are a little different. Is that angle equal to 45 degrees? It's got to be in between 90 degrees and 180 degrees. What is the angle measured halfway between 90 and 180? Five gets me. Go ahead do it. Calculating. What'd you get? 90 plus 180 divided by 2. Oh, that part. 90 plus 180 equals divided by 2. Average. 135. Okay. In terms of radians, it would be 3 pi over 4 radians. Okay. Now, coming down here, hopefully we've seen the pattern now. Down here, it's going to be negative root 2 over 2, negative root 2 over 2. If we count radians, here we went 1 pi over 4. 45 more degrees would be 2 pi over 4, right? Which is pi over 2. 45 more would be 3 pi over 4. 45 more would be 4 pi over 4, which is 1 pi. So down here, it would be 225 degrees if I added 45 to that one, or 5 pi over 4 radians. 45 more puts me at 270, or pi over 4 more puts me at 6 pi over 4, which is 3 pi over 2. 45 more puts me at 315 degrees. Or 7 pi over 4 radians. Okay? Tomorrow, we'll do the hard ones. We'll do 8 more tomorrow. Okay?